Thermo's overall approach to PFAS testing is really quite comprehensive because we have a broad range of items in our portfolio, such as consumables, instrumentation, and chemical reagents. And what we try to do at Thermo Fisher is create start-to-finish workflows. That is, from sample collection all the way through the final report. A lot of contract laboratories are doing PFAS testing for regulations, and they need to be efficient and have very good cost per analysis. PFAS chemicals have been ubiquitous for a long time. They tend to bioaccumulate in both wildlife and in humans. And more research is needed to understand what are the toxicological effects and where are they in the environment.
What makes PFAS so hard to analyze is that it's everywhere. Alongside that, you have these low part per trillion detection limits that we're trying to reach. So together, it's just very difficult to be so careful to reach those levels.
So for targeted AOF or EOF, we would use the Extriva automated solvent extraction instrument, and we would extract mostly solid samples through that instrument, and then we collect the sample and we would analyze it by LC-MS. For screening, we look at combustion IC as our primary instrument for analysis. The sample is adsorbed onto some carbon columns. We combust that under pyrolysis, which is inert gas at high temperatures, and then we oxidize it and hydrolyze it into the acid forms of those compounds. In particular, we're focusing on PFAS. Then it's bubbled into DI water and it now becomes fluoride, and then we're happily there to analyze it by fluoride. So we're using our strength ion chromatography combined with a sample prep instrument on combustion IC.
Thermo Fisher Scientific has application notes ready for all of the major EPA methods such as 533, 537.1, EPA 1633, Safe Water 846, and we have the triple quad mass spectrometry portfolio that's ready for these methods. For instance, the TSQ Altis Plus is the most sensitive platform, and it is the future-proofed solution for these methods and methods in the future.
It turns out that there are over 50,000 PFAS transformation products, also chemical products that are out there. So we need a non-targeted approach to find these compounds. And generally there are two types of approaches that we take. One is with Orbitrap high-resolution accurate mass instrumentation, and also coupling that with a software PFAS workflow that leverages compound databases, spectral libraries that have been created for PFAS, and also statistical analysis to say, hey, what could be in this sample that might be PFAS? What is of interest in the sample compared to everything else in the background? And then after that, how do we annotate these PFAS? With combustion ion chromatography, we're seeing pretty large organic fluorine measurements around different contaminated sites where PFAS was used. So this is telling us that that fluorine is coming from PFAS. And so what this gives you is a way to identify hotspots when an investigator is looking at, for example, a landfill site, and they want to see, well, could this be a potential area where there's a lot of PFAS coming into the groundwater? They can take that measurement and relate it back to targeted and non-targeted work to understand what might be underneath that organic fluorine peak. So it's a very interesting technology. They both work well together, and I think that's something that Thermo Fisher offers that's very unique.
So Thermo Fisher Scientific is working with the regulatory bodies that are developing these methods so that we can stay ahead and make sure that we are ready to help customers with implementing these methods. As these regulations come down the line, we also expect higher sample throughput requirements from contract testing labs or municipalities. And so we're also looking to have more automated solutions so that it remains accessible for labs to meet these challenges.
I think Thermo's mission is an awesome mission to make the world healthier, cleaner, and safer. And I think PFAS is a really good example of how Thermo's mission is being accomplished here.